Hello, everyone, and welcome to iFi Live. I'm Ron Insana, the CEO of iFi.AI. We're, of course, a new platform for individual investors, investment advisors, and others who are looking to use AI tools to enhance their results in financial markets. However, iFi Live itself will now be the stopping point for you to get all things AI, which, of course, is one of the hottest topics, not just on Wall Street, but certainly on Main Street, in academia, and around the world. As you know, it's become an extremely hot topic when it comes to investing, but it also has implications far beyond Wall Street in the way we work, the way we live, and possibly even the way we think, along with the way computers think as well. Joining us now to sort of deconstruct AI, its history, where we are now, and where we're going from here is Melanie Mitchell. She is the author of Artificial Intelligence, a guide for thinking humans. By the way, this is a New York Times top 5 book if you would like to understand the origins of AI and its future, both its risks and rewards. Melanie, thanks for being with us. Appreciate you taking the time today.
Thanks for inviting me. Great to be here.
So as I was going through your book, I was kind of shocked to learn that at age 63, AI is older than I am. Before we kind of get into the current state of affairs, can you kind of walk us through a little bit of the history that dates back to the mid 1950s when we thought computer scientists were solely working with punch cards and ones and zeros in ways that were far more simple and simplistic than was actually taking place at the time.
Yeah, so the field of AI often traces its origin to what's called the Dartmouth Summer Workshop, which was a 2-month workshop organized by people, mostly mathematicians, who are now known as some of the pioneers of AI: John McCarthy, Marvin Minsky, Claude Shannon, other luminaries of the field, who really were quite optimistic at the time that we would have something like human level AI within a decade or a couple of decades, sort of what people are predicting now. So these kinds of predictions go way, way back.
So, but we have gone through, multiple technological revolutions since then. We've gone through the electronics phase, we've gone through the computer age, we've gone through the internet and information age, and now we're in the middle of, or maybe at the very beginning of, AI as a practical vehicle for human use. How would you characterize where we are right now against that backdrop of expectations that it would have happened so much faster?
Yeah, so in 1956, which is when this Dartmouth Summer Workshop happened, the pioneers of the field set out certain goals that they thought could be reached pretty soon. Have computers learn on their own, have computers be able to use natural language, be able to do machine translation, to do a lot of the things that we're seeing finally now within the last decade or so. And the way that it's come about was really different than what these pioneers expected. They expected that really we humans would be able to program in logic into machines, and machines would be able to use sort of logical processes the way they thought humans did in order to think. But it turns out that thinking is a lot more subtle than that. And what the way that things work now is that we have these neural network models, sort of based on ideas from how the brain might work in a very rough way, that are trained on vast amounts of data, whether it be text, images, videos, any kind of data that now can be scraped from the internet at a very, very vast scale. And that's really what it's taken to get to where we are with what's now called generative AI.
And yeah, would you explain that term? I mean, for those who are not familiar with it entirely, I mean, we talk about AI in a very generic way. What is generative AI relative to the other types of AI that people kind of sling around rather loosely?
Yeah, there's many different types of AI. People might be familiar with things like Deep Blue, which played chess at a grandmaster level, or AlphaGo, which beat the best Go players. So those are systems that don't actually generate text or music or videos or anything. They just figure out, how to move in a board game, how to take actions. Whereas now we have things like ChatGPT or DALL-E or Sora, these systems that generate text in response to us prompting them, or generate images or generate videos or audio. And these are, a kind of different approach to AI, that, but we've seen in movies for decades. Think the Star Trek computer that could have a conversation with you, or
2001.
the
Yeah.
movie Her, which has gotten a lot of
Her.
press lately. But now we're seeing something kind of like that. We have chatbots and text to image programs and so on that can generate content.
And fundamentally, there's been a line of reasoning that suggests that these improvements, if you will, and we can debate later whether or not they're improvements or not, are going to radically alter the way in which we work and live. Whether they replace humans on the job, whether they, in fact, mimic or exceed the ability of humans to think and reason. Are some of those claims overstated, even given how sophisticated some of what we see, as you say, Sora or Chat GPT or IBM about to enter quantum computing and using that for these deep learning models? Are we overstating how close AI is to human intelligence?
There's a lot of debate about that. My personal opinion is yes, we are. And I think the whole history of AI has shown that we often underestimate human intelligence, or think about it in maybe the wrong way. So, for example, it was speculated back in the 1970s that if we got a computer to play chess at a grandmaster level, that would be very close. That would be a milestone that shows that we're very close to human level general intelligence.
Hmm.
And turned out, no, you could actually get a computer to play chess just by using a lot of brute force, search.
When you say brute force, yeah, what do you mean by that?
Well, this is, instead of just looking ahead a couple of moves the way that people do, these programs were able to look ahead hundreds of moves, or, a very large number of moves in the game that gave them the kinds of advantages that humans didn't have. So that's what I mean by brute force. And the thing is that these systems were not able to do anything besides play chess. They weren't general, and they couldn't be sort of trained to do new things. So it sort of showed us that playing chess could be done without sort of human level intelligence. And we've seen that with things like speech recognition or machine translation. These systems are very good, but they are not general in any sense. Now, people are starting to think that things like ChatGPT, which can do many different kinds of things, are sort of getting to that more general human-like intelligence, but they still have a lot of limitations. So it's really hard to say how close we are, because we've seen so many examples where people think we're very close, but it turns out that human-like intelligence is actually a lot more complicated and sort of um, not visible to us at our conscious level what's going on. So,
So
yeah,
Is-
I mean,
if we can back up for a second, then we have to figure out what AI is good at and will be used for versus whether or not it's going to replace us. I imagine is kind of where we are in this process. Obviously, in the business that I'm in, we're looking at it for market forecasting, portfolio analysis, asset allocation modeling, things like that are germane to financial markets. And obviously, we have also fast food restaurants, quick service restaurants using it with voice recognition, payment systems, food delivery, and the like. When you look across the field right now, what do you think AI is going to be most useful for?
yeah, that's a great question. I think many kinds of tasks are going to be replaceable with AI systems, but the problem is that they're not always trustworthy.
Hmm.
And so if
Well,
there's
neither are people for that
neither
matter.
are people, but in different ways.
Yeah.
I think that, in applications where it's not kind of uh, a life or death matter, or if you don't need the system to explain to you why it made a particular decision, um, and some mistakes can be tolerated, then the systems are going to be very good at those kinds of tasks and maybe replace people. I also think they're not necessarily going to completely replace people, but they're probably going to be used by people a lot more in their jobs. Just like, computers in general didn't replace us, but they changed the way we worked. I
Mhm.
think the same thing will happen with AI, and that people will need to learn about how to use these systems.
You said something interesting that is reflected in your book as well, is that we don't necessarily understand AI and how it works, even as it's being programmed by humans who, when they look for how the deep learning models or neural networks arrived at a conclusion, it would take billions and billions of pieces of information for us to see how the conclusion was arrived at, but we still wouldn't know how or why.
Well, that's kind of analogous to the brain, right? I can open up your head and look at your trillions of neurons, and or 100 billion maybe neurons, and see, I see them firing, but I don't know, I can't understand exactly why you're making the decisions you make. But we can do some kind of imaging and more high level analysis on people's brains and get more insight into it. And people are trying to do a similar thing to these very large neural networks. They're trying to do sort of a kind of neuroscience of neural networks, where they actually look at probes that they can put into the neural networks and try and figure out certain things about how they're making decisions and representing information. So that's a big area now of AI, is really what's called interpretability, trying to make sense of how these systems are doing what they do. But it's hard, as you say, just as it's hard, neuroscience is hard.
And you make some interesting points about vision and image recognition with respect to this, which we think is imminent, and yet these programs that allow devices to see still make rather fundamental mistakes. Not necessarily whether something is a dog or a cat, but whether a blurry image can be identified as a dog, even though it's just a blurry image. Well, this gets into some, into the weeds a little bit about some of the, frailties of AI, but there are still hallucinations, there are still misidentifications. Um, so we're not there yet. I think is when I know your book was written in 2019, and I'm sure we're talking about today. It's still kind of the same.
Yeah, I mean, some things are the same. Things have definitely improved quite a bit since 2019 in things like computer vision and
Yeah.
natural language processing. But there are still sort of failures of what I call failures of understanding, that the system has trouble understanding the world the way that humans understand it. One example I really like, there was a guy who posted this on Twitter. He was driving his Tesla using the autopilot software, and it kept slamming on the brakes at a particular place. And he couldn't figure out why. Why is it stopping? And then he looked up and he saw this billboard that had this ad with a police officer holding up a stop sign. And the car was like, oh, there's a stop sign. But it didn't understand sort of the context of an ad on a billboard that wasn't really a stop sign. We humans understand a lot of things about the world that are never sort of written down or might not be encountered very often. But we can deal with those kinds of unexpected situations still better than most AI systems.
Yeah, and you make the point that also that's very interesting to me, and I didn't realize this, that the machines don't always just learn on their own. That there are maybe sometimes scores, if not hundreds or thousands of individuals who are plugging data points into these networks in order to enhance the capabilities of the machines as they learn. So they're not fully like the cars that you mentioned. The machines themselves are not yet fully autonomous.
No, not at all. I mean, we have lots of companies now that are, their main product is labeled data for machine learning, that humans are then labeling, text and images and so on, so that machines can learn from it. And that's a lot of there's a lot of human work underlying all of these big AI systems, not just the people programming the systems, but the people training them. So these systems are not autonomous at all in their learning. And that's, that becomes an issue, because how do we get more and more data for them to learn from? And that's going to be a scaling issue going forward.
And it's interesting because in a certain sense, that flies in the face of what we've heard from some individuals like Jensen Huang and NVIDIA, which is the darling of the AI space right now when it comes to the types of computer chips being used for artificial intelligence. He suggested recently that at some juncture we will not need coders anymore, people who write software code, that the machines will code themselves. Is that an overstatement? Is that hyperbolic? Or given what you just said, and the scores, the countless number of people being used to plug in information,
Yeah.
we haven't reached escape velocity in that regard.
No, I mean, you say at some juncture, so it sort of depends how far in the future that is.
I think he said within 10 years, if I
Yeah,
recall correctly.
it's hard to predict, of course, what's going to happen in 10 years, but I think right now these systems are not reliable enough to code on their own, and they need human created data. And, one proposal has been, well, can't they just generate data that they themselves can then learn from? Uh, it's a little bit like, a snake eating its own tail. It might end up that this just just devolves into these systems not kind of getting worse and worse, because they're being trained on the data that they themselves generate rather than new data that humans have generated.
Although you do raise the issue of, and this is a phrase I'd never heard before, called back propagation, in which the machines do learn from countless trial and error episodes that take place within the machine itself. And as more data come in, the machine becomes smarter and smarter, and makes fewer and fewer mistakes over time.
Right, up to a point. And that's, there's two things to say there. One is it needs a lot of data that humans have curated, but also, even if it's learned from all that data, if something happens that's quite different from the kind of data it's learned from, it might not be able to adapt what it's learned to a new situation. The stop sign on the billboard is one
Mhm.
example. And people call these edge cases, or sort of out of distribution cases. And those are
We
the
used to call them
ones.
black swans in the financial markets, but that's okay.
Yeah.
Yeah, yeah.
And it turns out that if you're deploying AI to, millions or billions of people, of users, these black swans can happen. And
Let's talk about that a little bit, because this is where most people raise the issue of Skynet and Terminator. That at some juncture, the system, or quite frankly, 2001: A Space Odyssey. You pick your poison as far as these movies are concerned, about some apocalyptic scenario in which the machine does become smarter than humans, does make a decision that is detrimental to humans, whether it's launching a nuclear war, as we saw in war games, or at least the threat of, or some other decision like that. When you look at the risk and reward proposition with respect to AI, is that the type of thing that still keeps you up at night, or is it something more subtle than that?
well, the getting smarter than humans part is not the part I'm most worried about right now. It's mostly the opposite. It's that these machines are too stupid, and yet we treat them as being smarter than they deserve to be called, and that we trust them too much. And I think we've seen problems with that over and over again. Google has this new AI overview feature. I don't know if you've seen it, where
Mm.
you put in a search query, and it will, instead of returning a bunch of web pages, it will give you it will just give an answer to your question and give a couple of sources. Well, it turns out that that's extremely unreliable. Even though it sounds very confident, it will give you an answer that's just wrong and sound very confident. But the problem is, you might not know that the answer is wrong, and you might trust it too much. So I think that's the more immediate problem. Whether machines are going to, get smarter than humans, whatever that means. I
The
mean,
singularity, as Ray
yeah,
Kurzweil.
I'm not
Ray
so
Kurzweil.
worried about that.
Yeah.
I think that's very speculative, and still, kind of way down the list of the things that I'm personally worried about. I'm more worried about humans using these machines in ways that are harmful.
And let's talk a little bit about that because there is an AI arms race. I mean, it's not just something we're developing here in the United States for the betterment of mankind. We've seen in other societies, China in particular, using all manner of tools to control the behavior, if not potentially the thoughts of their populace. We've seen disinformation and misinformation campaigns that are being run through various social media networks that are using AI foundationally to do this. How troubling is that? And how do societies get a handle on that proliferation of bad information that people will, in many cases, take at face value?
Yeah, that's a really big problem. It does worry me a lot, and I think the fact that AI systems can now generate images that just look incredibly realistic, or videos, or voice
Oh, my son
voice
sends me
cloning.
TikToks of politicians, and it's all deep fake material. Some of it's like extremely funny, but a lot of it's wildly inaccurate as well.
Sure, but it can often be very convincing
Yeah.
if you don't know, if you don't know what the real truth is. So I think that's going to be one of the biggest challenges we face in the near future, is sort of the assault on truth, the fact that we're not going to be able to tell what's true and what's not.
Is this in part going to be a generational problem? Because many of us who are older, who have lived experience, or who actually know the people who might be getting parodied on TikTok with again, a great deal of believability, whereas younger folks may not have had enough experience, they may not have made enough contacts, may not have spoken to enough people in either positions of power, authority, or education to be able to suss out the difference from what they're seeing on these social media networks versus someone else's lived experience who might have been around the block a couple times.
I don't know. I think you're giving the us older generation too much credit. I think we're just as
Well,
gullible.
that's true too. Yeah.
We're gullible as the next the next
Yeah.
generation. No, I think it's gonna the disinformation. We're all vulnerable to it, and I think we're if it aligns with something we believe in, we're much more likely to believe it,
Yeah.
and that's going to be a problem for everyone.
Is government the appropriate institution, if you will, for lack of a better description, to intermediate or step up and regulate the types of advancements that are going to be made here, or are they too far behind the technology?
Right. I mean, this is like, people say about democracy, government regulation is the worst possible system, except for all the other the
Yeah, right,
others.
exactly. Yeah,
So, governments are, they're not great at regulating. They're not, we've seen that so many times that they're very bad at developing technology regulations,
yeah, but
because
self-regulatory organizations aren't that great either.
no, and I don't trust the big tech companies to regulate themselves. And I think so. Government really is the way that we're going to have to regulate AI. The European Unions are, far ahead of
Yeah,
the US, I think, in trying to set up laws. And they've set up laws about deep fakes and other kinds of, possible harms from these technologies. But no one really knows how the right way to regulate these systems. And it's just going to be an ongoing evolution, I think.
OpenAI, which has clearly been at the forefront of the latest, iteration in this regard, has talked about decentralization. It's talked about open architecture. It's talked about not for profit, and we're finding out that maybe Sam Altman and company are not quite as egalitarian as we might have expected, and that there's a huge multiple currently put on their business. Can you talk about them with respect to whether or not they're in the vanguard and whether or not they're leading in the right direction?
Wow. This is a little bit out of my own area of expertise. I have personal opinions, but I worry about their ironic lack of openness, given their name, their, kind of ethos of move fast and break things, which I think that has caused a lot of harm by technology in the past. Uh, and their focus on just scaling up as fast as possible in terms of compute power, in terms of data. This has given caused a lot of issues that people have talked about with respect to their business, that they you know, these approaches use a huge amount of energy
Hmm.
and water, for cooling data centers and so on. It also requires them to get high quality data. And so there's all these lawsuits now against them for copyright infringement and so on, for, just basically stealing digital media, even
Hmm.
if it's
Yeah.
copyrighted, and saying, well, it's fair use.
Yeah. So,
So
some of us would oppose that. Yeah.
yeah, well, we'll see how that the courts deal with that. The courts are another place where this kind of regulation might happen, and the courts are, I think, in terms of technology, perhaps as clueless as government to really figure out how to deal with it. So it's an interesting time, but I'm
Let's
not.
not just
Yeah, go
go
ahead.
ahead. No, no, go ahead, please. You're not.
No, I was just say, I'm not thrilled with any of the big tech companies and their kind of rush to be first at everything.
So the flip side is, what are you thrilled by, or conversely, not conversely, but you know, what do you see as we talked about the risks? What do you see as the rewards? I mean, where will this be best used and help people the most?
Yeah, I mean, I think there's a lot of potential for use in all areas of science and healthcare. We've already seen incredible results from, say, applying AI to protein structure prediction,
Mhm.
to weather forecasting, to climate prediction, creating new materials. All of these things are people working with AI, as opposed to, say, AI replacing scientists, but
Mhm.
people using AI to make progress. And, in medicine, there's huge possibilities and already a lot of successes in diagnostics, in treatment planning, in just dealing with the huge amount of literature in the field and helping to summarize it. Uh, I think that's the areas I'm most excited about in terms of applications of these technologies, that they're going to really make a big difference.
Now, you spent a lot of your career focusing on cognitive science. So when you have to compare the human brain and the AI brain, if you will, I mean, what's the thing right now that you're most focused on in that regard?
So I'm interested in our abilities to reason about new situations. And the way we do it is using analogies. People often in all kinds of domains use analogy to make sense of new things. And I want to know how people do that. And I also want to get machines to be able to do it as flexibly as people. So that's what I'm working on now.
And with respect to the thing that we talk about a lot, the singularity, the notion that uh, artificial intelligence will exceed human intelligence at some juncture. Ray Kurzweil, who popularized the idea along with Peter Diamandis and others, um, have consistently suggested that it is imminent, and yet we're not there yet. How imminent is
Well, as I think someone said, it's always 20 years away.
it?
It
Yeah.
used it always has been, and it always will be. Uh, that's what the predictions are. I who knows, right? Making predictions is all. Maybe that's part of your job, forecasting, but
Yes.
it's not always an easy thing to do. But I think that, again, people underestimate human intelligence. There's a famous paradox in AI called Moravec's paradox, which says that the things that we find the most sort of challenging, like playing chess at a grandmaster level and so on, turn out to be easier for AI systems than the things that we find most automatic, like walking across a crowded street without bumping into anyone.
Mhm.
And that's still true. The kinds of intelligence that we have is different from the kinds of intelligence that machines have. I would say that machines maybe are already smarter than people in many dimensions, but I think they are very far from being smarter than humans in other dimensions, and all of those dimensions matter for a lot of the jobs that we're talking about.
And second to the last question, which I think we haven't touched on, but is really, and it's to a certain extent, maybe some people may view this as a fringe question, but machines don't emote yet. There's a lot of talk about how machines can create music, they can create art, they can write a great novel, and yet that's often based on innate human experience, emotions, and synaptic activity that is not found inside something that's built with copper and other materials. I mean, will machines get to the point where they can, again, lack of a better description, feel?
Well, okay, there's different that's really a philosophical question.
Yep.
There's many different ways to argue it. You know, there's a famous philosopher named Margaret Bowden who wrote an article saying robots won't take over the world because they don't care.
Well,
And
that might be why they take over the world.
right. So we don't understand what feeling is in humans. There's obviously the whole arguments over like consciousness and sentience and all of that is people throw about those terms, but they don't really have a very clear sense of what it means in us, much less machines. The other way to argue it is like we are in some sense machines. We're made up of cells that have like kind of machine-like properties, and if that's kind of a proof of principle that machines could feel, but we don't really understand it. It's very complex. So I don't know what it even means for a machine to feel. So I'll leave that to the philosophers for now.
Final question. You've been doing this for a while. What do you use AI for?
Well, we all use AI every day in our lives without even knowing it. You get in your car, you program a destination into your GPS, it maps out a route. That's AI. You you dictate a text to your phone. That's using AI. You want to translate something from a foreign language into your language. You use AI. So all of us, use that. Using Google search is using AI. So it's really everywhere, even in places we don't realize. But I actually use my use of more generative AI tools like ChatGPT or Dolly. I use them. I probably less than a lot of other people.
Hmm.
A lot of people I know use them for writing or for doing data analysis and things like that. I use them for things like formatting tables and pictures and for uh, also just to play with them to see how they do on certain things. So in that sense, I'm not a big user of generative AI, but I just like everyone else, it's everywhere in our lives.
All right, Melanie, it's a pleasure to have you. Thanks for being with us today. Appreciate you joining us on the inaugural edition of iFi Live.
Great, thank you very much.
Melanie Mitchell, our author of Artificial Intelligence, a guide for thinking humans. I'm Ron Insana, and we'll see you again soon.